Hello friends, welcome to all in my YouTube channel all about civil engineering by Pravin whose custom link is given here www.youtube.com/c/Pravin, and here this is the uh, channel associated with the PM Academy, so which is the academy for online education. Recently I am starting the uh, offline academy also, PM Academy, so from KG to PG online tuition or offline tuition for all subjects. It may be related with the mathematics or English and mathematics for up to 7th or 8th standard or 9th standard, and afterward 10th, from 10th to 12th it may be for mathematics and science. So mathematics and science, and then as far as your engineering is concerned, so first year engineering subjects, engineering mechanics, and also for the strength of material, fluid mechanics, estimation, costing, and many more subjects related with the civil engineering. So today I am giving you most important knowledge session for civil engineers. So those who need this knowledge, those who work on site, or those who are in the last year of civil engineering, they need this knowledge. So very important topic today. I am discussing very important topic. So we'll go first, building material. We'll see the building material. There are different types of materials used in the construction. It may be a cement, sand. There are two types of sand: river sand and crushed sand. So machine sand, again we can say machine sand. M sand is machine sand. So it may be a crushed sand. You can call it as crushed sand. Then coarse aggregate 20 mm, 40 mm, steel, bricks, blocks, water, tiles, wood, aluminium or UPVC pipes, waterproofing material, plumbing material, and electrical material. These are the materials. Now, as far as cements are concerned, there are different types of cement: OPC and PPC. That is ordinary Portland cement and Portland pozzolana cement. These are the two main types used in the industry. So other top types are rapid hardening cement, sulfate resisting cement, blast furnace like cement, and high alumina cement. These are based on the requirement. These are based on the requirement of the owner or requirement of construction site. So only two main types are there. They are OPC and PPC. That is ordinary Portland cement and pozzolana Portland cement, or Portland pozzolana cement. You can say. Gavasre. So there are different grades of cement: 43 grade OPC, 53 grade OPC, and 33 grade OPC. Here G refers for grade, and 43 or 53 refers for compressive strength of cement at the end of 28 days of cement cube casting and testing and curing. Correct? So first you need to cast cement cube, then you test it, then you uh, cure it. Firstly cast it, cure it for 28 days, and then test it, and its strength should be 43 Newton per mm square. As far as PPC is referred, it is 33 grade of cement. Same thing will be there. Then we'll go for application of different grades of cement. Where to use PPC or OPC, or OPC 43 grade, OPC 53 grade. So as far as PPC is concerned, used in the masonry and plastering work. So it can be used for RCC work. OPC 43 grade for masonry, concreting, plastering work. And as far as OPC 53 grade cement is used for RCC, as to achieve strength rapidly and enable speedy work progress. If you want speedy work, then you should use this type of cement. Then points to be remembering on cement. सीमेंट के बारे में हम क्या ध्यान में रख सकते हैं, और what we need in mind or memorize something. So density of cement is 1440 kg per meter cube. Weight of one bag of cement is 50 kg. Volume of one bag of cement is 0.0347 meter cube, or 1.23 cubic feet. Storage space required approximately 20 bags per 1 cubic meter space. 1 cubic meter space में आपके 20 bags बैठ जाएंगे. So this you need to keep in mind whenever you are work as a site engineer. So cement storage. Cement should be stored on raised platform, because if it comes in contact with the moisture, it will be of no use. So it will be of no use. So keep it as dry place and raised platform. So 0.6 meter away, that is the distance free space to be maintained from outer walls. The cement store should be waterproof. Approximate reduction of strength with age in a watertight storage condition are, so as far as age of cement is 3, age of cement, watertight conditions 3 months. So loss of strength will be 5 to 10%. If 6 months we have stored cement, it loss is 20 to 30% loss. Then if we store 12 months, that is the 1 year, it may be 30 to 40%. After 12 months, it will be of no use. Whether you store anywhere in dry place or anywhere, it will be of no use after 12 months. So then test for cement, that is the different test for cement. So need to check the property of cement, need to check the strength of cement. So first is the field test, then laboratory tests are there. Then field tests are general tests. The first you can see the color, then physical properties, then presence of lump. Throw the cement in the water, clear. And then whenever you cast the concrete, make it its ball and play like our cricket ball. So this may be the test. Last test I have told you, this is related to the concrete, this is not related to the cement. So cement tests are color, physical properties, presence, then throwing the cement in water. Then laboratory test, fineness test, soundness test, consistency, strain test, then setting time test, bulk density, specific gravity, chemical composition of cement. So in general, setting time of cement should be it should be maintained up to 30 minutes. So it should not be less than 30 minutes, or it should not be greater than 30 minutes, or it may be so there are two: initial, final setting. Initial setting time should be up to the 30 minutes, and afterwards it may be a longer way. Then as far as uh, why we assess initial setting time 30 minutes. So after 30 minutes we cannot use the prepared mix, that is nothing but setting time. If we use cement and make a concrete, and if we use that concrete after 30-35 minutes, so it will be of no use, it will be not gaining the strength. So that's why the initial setting time is up to 30 minutes. So 0 to 30 minutes we can use the whatever prepared concrete. Then field observation. So there are field observation, what I have field test for cement. So first is the color should be uniform, it will be a light greenish shade, or it should be a typical cement color, that is light greenish shade, green color. Then physical properties, the cement should be smooth when touched in between the fingers. If we insert a hand in a bag of cement or heap of cement, it feel cold, not warm. It should feel cold, not warm. If we throw small quantity of cement in the bucket full of water, then it should sink and not float. It should sink in the water, it should not float on the water. So then presence of lumps, if cement should be free from any hard lumps, such cements are formed due to absorption of moisture. Then compressed cement test, compressive strength test. So to determine the compressive strength of cement, the cement mortar mix of ratio 1:3 to standard sand in or sand is mixed. Then 75 mm cube mold used. Otherwise you can mix only cement. So 75 mm cube mold used, vibrating machines and cube testing machines used. At the end of 3 days, 7 days, 28 days, result obtained and documented, and check the result. So these are the some result given in the IS requirement. The Indian standard, IS means Indian standard requirement. So your cement should give this minimum this much strength. So these are the IS requirement. If cement is failed to give this much strength, then this cement is of no use. So if 33 grade PPC cement is there, IS 269 1989, they mentioned 3 days strength should be 16 Newton per mm square, 7 days strength is 22 Newton per mm square, and 28 days is 33 Newton per mm square. Then 43 grade cement, IS 81121989. Then IS 53 grade cement, IS 12269 1987. They have given the requirements. Then cube test format, this will be the cube test format. Their format contains different columns, that is the serial number, then date of casting, date of testing, then age in days, then weight, load, strength, average strength, sign and remarks. So now cement test, then setting time test. Initial setting time for OPC should be 30 minutes, and final setting time for OPC is 10 hours to 600 minutes. Initial setting time, the time to which cement can be molded in any desired shape without losing its strength, is called the initial setting time. That is up to 3 minutes, 30 minutes. Then final setting time, the time at which cement completely loses its plasticity and becomes hard. Becomes hard means after this we cannot change anything in the cement. We cannot change the shape of cement. So this is nothing but the final setting time. Then we, how to check the final setting time, initial setting time and final setting time, based on the wicket apparatus. So this wicket apparatus. Then fineness test. To check the proper grinding of cement, fineness test is determined by sieve analysis. As a thumb rule, the finer the cement, the best will be the cement. So BIS sieve number 9, it should pass through the BIS sieve number 9, Bureau of Indian Standard. BIS means Bureau of Indian Standard. Then soundness test. The purpose of this test is to detect the presence of uncombined and excess lime in cement by using Lee-Chatelain's apparatus. Soundness test is performed by using Lee-Chatelain apparatus. Then consistency test. It is defined as the amount of water that can be added to cement to produce a plastic paste of cement. So wicket apparatus. So consistency means we should make a paste, cement paste, plastic. We should make cement paste plastic so that we can use it, we can work on it. So it is workable cement, it should be workable. Then these are the CTM machine, different machines are shown. CTM machine, cement mortar vibrator, wicket apparatus, cube, concrete cube mold. Here concrete cube and cement cube mold is given. Cement cube mold is 7 centimeter by 7 centimeter by 7 centimeter. Concrete cube is 150 mm by 150 mm by 150 mm, that is 15 centimeter by 15 centimeter by 15 centimeter. Then wickets apparatus, that is a cement sieve machine. Sieve machine is there. Then here Lee-Chatelain's apparatus shown. Slump contest. Slump contest, there are different slumps. Slump we are taking for concrete, not a cement. We are taking slump for concrete. So concrete slump, maybe there are three types of cement. Already I have posted one video based on the slump contest. You can watch that video. Then there are three types of slump, that is collapse, shear types of slump, and true slump. Then here compaction factor test. This is also a test for workability test. So slump cone test is a workability test. Then sieve test, sieve analysis for aggregate. There are different, these tests are shown for aggregates, and as far as cements are concerned, that sieves are different. Then here silt content test, the beaker is there. Then sand or fine aggregate. Then as far as test for sand or fine aggregate, sand, both are same. Fine sand, medium sand, coarse sand. So fine sand grain size is 0.125 mm to 0.25 mm, uses for plastering purpose. Medium sand 0.25 mm to 0.5 mm, it is for masonry purpose. And as far as coarse sand, 0.5 mm to 1 mm grain size, used for concreting work and masonry work. However, now use of river sand is being substituted with M sand, that is machine sand or manufactured sand. You can say it may be a machine sand, or it may be a manufactured sand, or it may be a powdered sand, or it may be a crushed sand. You can take any one name. So there are, based on the different properties or different conditions or different technical things, they have their different names. Only some of the properties may change. As far as IS codes are concerned, IS code has given same name to the that is M sand is same as the manufactured sand, is same as the crushed sand, is same as the powdered stone sand, same thing will be there. But as far only technical changes will be there, one or two changes will be there, so that we'll see later on. Then as far as test for sand, there silt content, test of grading of sand, rubbing of test, visualization test, bulking of sand. Then silt content. So silt content, this is simple test with glass jar sand, water and sodium hydroxide or caustic soda is added, and the silt content is settled on top. It should not be more than 8%. So then these are the arrangement for silt content. So this is the beaker, volumetric evolution. This is, you can take water, then you can, this is silt, this is sand. Then silt test for sand is formula is V1 upon V2 into 100. This is given first volume of, here given V1 volume of silt, V2 volume of sand, then test for grading of sand. Grading is the fineness modulus of sand is index, then number of which represents the mean size of the particle in sand. Particle size distribution, we can say it as particle size distribution. The percentage of weight retained is equal to weight retained on each sieve gram divided by original sample weight into 100. So in percentage you can calculate. Then this is the apparatus called sieve test. So this is the sand material, then this is the tray, this is the, what we can say, we need the sieve shaker, sieve shaker, or manually you can shake, or by using sieve shaker you can shake, or by using manually you can shake. Then this is the set of sieves, then pan, then fineness modulus range. As far as is concerned, IS code is concerned, the type of sand, fine sand, its fineness modulus should be 2.2 to 2.6. Medium sand is 2.6 to 2.9. As far as coarse sand is concerned, 2.9 to 3.2. Generally, sand having fineness modulus more than 3.2 is not used for making good concrete. So there are, it affects on concrete. So whatever test we check for cement, or we check for the sand, and we check for the aggregate. As you know, the concrete is a mixture of cement, sand, and aggregate. So if you cannot take the results of this tests of in during preparation of concrete, then it will be of not you make a good concrete. So then fineness modulus of weight of sample is 2 kg. Specification as in IS 383 1970. Cumulative percentage of weight retained is equal to cumulative weight retained divided by sample weight into 100. So percent of weight passing is equal to 100 minus cumulative percentage weight retained. Then fineness modulus is equal to summation of cumulative percentage of weight retained up to 150 micron divided by 100. Then how to check zone of sand? How to check zone of sand? For example, ISU in micron, so 10 mm, 4.75 mm, 2.36 mm sieve size. These are the sieve sizes. 1.18 mm, 600 micron, or 300 micron, 150 micron. Then pan, then weight of retained in gram. So you write the weight of retained in gram. Then cumulative percentage weight. So cumulative, you take the cumulative of this year. Then cumulative percentage retained. Then cumulative passing. Zone 1, zone 2, zone 3, and zone 4. So zone 1, zone 2, zone 3, zone 4, they are given in the IS code requirements. IS code requirements. So then you can, these are given. So zone 1, zone 2, these are given in IS code, and here you will get the result. So check the result and then decide whether this sand is from zone 1, zone 2, or zone 3. Then fineness modulus, same way you can calculate fineness modulus. The sample is in zone 3. So generally having fineness modulus more than 3.2 is not used for making good concrete. Then fineness modulus can also be used to combine two aggregate and get desirable grading. Generally zone 1 and 3 used for structural concrete. So this is also most important thing. And as far as required for competitive examination, zone 1 and zone 3 sands are used for structural concrete. Structural concrete. So angle section, channel section, edge section, eye section. So this is structural skill and structural concrete. Then grading of so grading of sand. Sorry for a disturbance. Uh, so it may happen. It may happen. So now grading of sand for different zones. So ISUs and grading zone as far as IS codes are given. Then test for sand. Then rubbing test. Rub the sample of sand with the wet palms, and good clean sand will not stick in the hand, whereas you need to test it for silt content. Then bulking of sand. Bulking of sand is a phenomenon to increase its sand volume due to increase in moisture. So bulking increases with increase in moisture content up to certain limit, and further increase in moisture content or content decrease in volume of sand. If the bulkage value is approximately 30%, then additional 30% extra sand in volume batching up to 50% is considered for bulkage. Then test for coarse aggregate. So crushing test, abrasion test, impact test, soundness test, shape test, specific gravity and water absorption test. Then these are some IS codes. In IS code, they have given the procedure for test and their requirement, standard requirement. So you can refer this code, or in another video, I'll make one video based on the test on cement, test on aggregate, test on sand. So same thing will be, I am making another video. So here crushing test. So it is IS 2386 part 4. Then Los Angeles abrasion test, it is used for hardness. So IS 2386 part 5. Toughness test, the aggregate impact test is IS 2386 part 4. Durability test, soundness test, IS 2386 part 5. Then shape test, shape factor test, that is the IS 2386 part 1. Specific gravity and porosity test, water absorption test, again water absorption test. So this IS 2386 part 3. Then grade of steel. So grade of steel, TMT bar, thermomechanically tested bar, thermomechanically treated bars, TMT bars. Then different grades are Fe415, Fe500, Fe550, Fe600, where number denotes the minimum yield strength in Newton per mm square. Yield strength, it is defined as the stress at which the reinforced bar starts to exhibit plastic deformation. So it will start plastic deformation and ultimately it will lead to the failure. So this is the strength. Then test for steel, tensile test, yield stress test, percentage elongation test, bend and rebend test, unit weight of steel, chemical analysis test. Then test for steel, grade of steel, yield strength, ultimate strength and percentage of elongation. When Fe500 is used over Fe400, about 15% lesser consumption of steel in construction, the percentage of elongation is as the measure of ductility. So here you get some ultimate strength is different and yield strength is different. If you use Fe415, you will get ultimate strength as a 485 Newton per mm square. That is, the elongation is 14.5%. This is allowable. This is as far as IS code is concerned. Then test for brick crushing strain test, water absorption test, presence of soluble salt or efflorescent test, hardness test, shape and size test, soundness test, impact test. Then compressive strength of brick. So compressive strength of, this is as per IS code. This is IS code given. So first class brick, it is 105 kg per centimeter square. Second class brick, 70 kg per centimeter square. Third class brick, 50 kg per centimeter square. Common brick, building brick, it is 35 kg per cm square. Then water absorption, it should not be exceed 20% as far as brick is concerned in 24 hours. Then presence of soluble salt or efflorescence, it should not be then more than 10%. Then hardness test, then soundness. If we struck two bricks with another, it should give a ringing sound. This is also a field test for brick. Then impact test, shape size test. Then important points to remember. What you need to remember, आपको क्या point आपके दिमाग में रहने चाहिए. Then density of cement, 1 bag of cement, its weight, volume, initial setting time, final setting time of cement. 20 bags of cement equal to 1 metric ton. Then specific gravity of cement 3.15, grade of cement 33, 43, 53. Then as far as sand is concerned, density of sand 1400 to 1500 kg per meter cube. Permissible sand content up to 8%. Then specific gravity 2.5 to 2.67. Types of sand, fine and coarse sand. Coarse sand is also called as aggregate. So coarse aggregate, we can say coarse aggregate. Then density is 1500 to 1600 kg per meter cube. 1 meter cube of 20 mm metal is equal to 1550 kg if density is 1550 kg per meter cube. So specific gravity is 2.88. Then steel, as far as density of steel is 7850 kg per meter cube. Grade stock steel Fe415, Fe500, 550, 600. You can get 500D, 550D. Then yield strength Fe500, 500 Newton per mm square. Ultimate tensile strength for Fe500. Ultimate yield strength is different and ultimate tensile strength is at ultimate tensile strength steel will break. Steel will break completely. So that is 560 Newton per mm square. Then testing of steel, then marking of steel. The most common type of marking in Czech Republic is by 5-digit number, eventually 6 digit. For example, 10, 335 or 11, 373, where first 2 digit is the material group sign, second 2 digit for steel from group 10, and other fifth digit is some important property. For example, good weldability, cold steel. One is the normalized steel. Then machine steel. 33 is 1/10 of yield strength in MPa. 37 is 1/10 of tensile strength in MPa. Then complementary 6 digit, that is state of steel. For example, one is normalized steel. Then basic properties of reinforcement steel. Volume weight. There is density. Volume weight means density. Volume weight is density. Then modulus of elasticity. Then thermal expansion, thermal conductivity, tensile strength. Then in relation to carbon content, in relation to temperature, the basic properties of common type of change reinforcing steel are given in next table. So mark of steel, then standard requirement, and then minimum ductility given in the table. Then here shape of reinforcement steel are given. Then tensile test. So tensile test is one of the most common tests. The test is described in standard EN 10002. So you check what is meant by 10002. Then gauge length L, length of cylindrical or prismatic portion of the test piece on which elongation is measured at any moment during the test in meter. Then original length, then final length, then elongation, ductility is equal to ductility percentage elongation after pre-fracture is equal to A is equal to LU minus L0 upon L0 percentage. LU is final gauge length, L0 original gauge length. Then extension, then percentage reduction of area Z. So if length is increased, area will be decreased. S0, SU, S0. So S0 is the original cross sectional area. SU after fracture area. Then maximum force. Then stress. Stress is force divided by area, original area. Then tensile strength. Tensile strength is equal to stress corresponding to maximum force divided by maximum area. Then yield strength. Yield strength is yield area, yield force required so exhibit yield phenomenon. Point is reached during the test at which plastic deformation occurs without any increasing force. Without increasing force, there will be plastic deformation will be there in the steel. So that force we can take, that is Fy divided by S0. Force at point yield. Then proof strength. So stress at which extension is equal to 10 specified percentage of the gauge length. The symbol used is followed by suffix RP, R0.2, anything. That is the RP is proof strength. Then this is the stress strain diagram. Steel with yield point and here steel with proof strength. So already I have placed one video based on the explanation of this diagram. This diagram such as stress diagram. The stress strain curve. This is stress we can take. This is strain. So yield strength. This is elastic limit. Proportionality. This is proportionality. Elastic limit. This is tensile strength. This is fact. Then test piece. The shape of dimension test piece depend on the shape and dimension of the metallic product. The machine properties of which to be determined. Usually obtain a sample from the product. However, product of constant cross section may be subjected to test without being machined. The cross section of the test piece may be circular, square, rectangular, and annular, or in special cases in some other shape. Then determination of original cross section area. The original cross section area S0 shall be calculated by measurement of dimension of the test piece, that is its diameter. Arithmetic mean of two measurements carried out in two perpendicular directions. Then product of ribbed surfaces. Then determination of original gauge length. Then these are the dimensions of circular cross section pieces. So here different K, then diameter D, original cross section area, then original length, and then total length. Then determination of final gauge length. The procedure is given. You just read this procedure, or this is the standard procedure. So whenever I am making a video for different test on cement detail, that time I will explain in detail. Today I am giving you just the information. For this information is useful for the your competitive exam preparation, like GATE. So it may be in the future, that is the in February you will having GATE 2021 civil engineering. So this may be a useful. So here figure 37, LB, LA, LC, LU, LC, so delta. So this is the gauge length, or we can calculate. This is the figure after test. This bar is after test. This is still bar after test. Then testing procedure. So testing procedure will be there. Then rate of stressing, modulus of elasticity of metal, then rate of stressing, then evaluation of result, determine values, then integral part of the laboratory report is stress strain diagram obtained from testing machine, completed by access, description, and scale. Everything you will get on computer generated results. So stress strain curve, and based on the stress strain curve also you should know the maximum strength, and theoretically also you can calculate and check the result. Then this is the vocabulary you should keep in mind: strain, cold worked steel, ductility, elongation, extension, final gauge length, then grip, jaw, original gauge length, percentage elongation after fracture, percentage reduction of area, proof strength, reinforcing steel, ribbed stress, and stress strain diagram, weldability, yield strength. So thank you for watching the video. If you like it, please do share it and subscribe the channel for more such fruitful videos. And watch this video carefully, because this is useful for the competitive exams. So most important for the civil engineers. Thank you for watching the video. If you like it, please do share it and subscribe the channel for more such fruitful videos. Thank you.